Hello everyone and welcome to the second part of the HandIK tutorial. Now the prerequisite is of course the first one, so if you haven't watched it, please watch it because everything in this video is built upon that. In here we are gonna do the crouching HandIK as opposed to the standing one, and we are gonna continue from where we left off. So let's jump into it. Now here we are in the standing HandIK function. And what we are going to do is actually duplicate both the standing HandIK and the get standing HandIK line trace parameters. So duplicate, and I'm going to rename it to crouching HandIK. And close the standing HandIK so I don't get mixed up with it. Do the same for the line trace parameters, the crouching. And it's actually not going to be the same, the line trace parameters, obviously, because they are going to need different kinds of line trace. Don't forget that in the crouching HandIK function you have to replace the parameter functions as well. Do it real quick here. And I would close this one as well because we don't need that. And go into the crouching one. Now we are gonna need actually an extra pin for the plus. So we're gonna do that in a moment. And the one we need is up vector this time. And as usual, we are gonna multiply it with a number so that we can control how far up or down it goes. Actually, it's gonna get below the shoulder, so we are gonna multiply it by -10 or -10. The values that work for me can be totally different than the ones that would work for you. It's really based on personal preference. For the forward vector, it's gonna be just 20 for me. I'm gonna leave the right vector at 40 for now. And one big difference is that this time the one with the many pluses is gonna be the starting point. And we are gonna actually add it to another value. So vector plus vector, and the one we are gonna add it to is gonna be another get vector right vector. Up vector, sorry. And we are gonna go way more below, -35. This controls how down does the line trace go, and just connect the addition to the end. Now let's copy paste it for the other hand. And as usual, change the right vector to its opposite, just -40. And now we have our line trace parameters. Now in the HandIK function, you remember we have the standing one. We now actually somehow add the crouching one to it. Now the way I am gonna do that is actually just first of all dragging it in. And what I actually want is check if at the standing either the left or the right hand has hit the wall. So we are gonna check the output of the booleans and connect it to an OR node, and that's gonna go into a branch. So if either left or right hand has hit the wall at the standing HandIK, I will just go and output that. But if not, I will check if the crouching has done the same So if the standing doesn't hit anything, I'm gonna go to the crouching one and return from the crouching. And just connect everything up. Now, as you can see, we have a few more line traces, which are vertical. And at this point, it looks like it's kind of working, but don't be fooled, it does not work at all. For one reason, you see it's looking pretty good there. Oops, it's not looking good anymore. And that's because we are using world rotation and the out hit normal align to the object. But that can give some pretty weird results. For example, the hand is always pointing at the same direction on an object, which is not very good. So we actually have to make a few calculations so that we can counter that. So I'm just gonna start with the right hand. And what I need to do is actually get my player's rotation, because that's what we are gonna compare the yaw to. Because yaw is basically the direction you are facing, and by the get world rotation node, and the target is our mesh, we get our own player's rotation. And for that, we are just gonna connect the bake rotator's yaw to our own yaw. It's not gonna be the good rotation, but at least now it's always facing relative to the player. Now we just have to add value to it, and that value is going to be -90, because we want to turn the hand 90 degrees, and based on if it's right or left hand, it's either 90 or -90. And now if we crouch, now it's pointing forward all the time, which is kind of good. But you will see soon that it works in one case, so when it's upwards, it's good. But when it's downwards, it's pointing at the other direction. So we will have to make a calculation that checks that relative to the object, what direction we are standing. And based on that, we have to multiply our pitch. So I'm just gonna create a normalize values function, which is gonna be a pure function. And what it will do is that by default, we get values from -270 to 270 degrees, and I don't like that. So to make calculations easier, we are just gonna create a small function that takes a value and just translates it to 0 to 360. Because, for example, -270 is actually +90. If you check a circle and go either direction, you can get the right angle. So we are just normalizing the angles. Now, and the way we do that is we check if the angle is smaller than 0. And if it's smaller than 0, we just add it to 360. Now the way that works is, for example, imagine -180. That's smaller than 0. And if we add it to 360, we get 180, which is exactly the same as -180. Same with 90 and -270. So that's how this function actually works. So just checking it, and if it's smaller, we add it to 360, and if it's not, we are just gonna return the same input. One extra thing I do here is I'm gonna round the numbers so that we don't have floats. That just makes it a little bit easier to work with. It's really just a preference, you don't have to do that. But in in my opinion, the maximum of 0.5 degrees doesn't really matter in this use case. So that's why I'm rounding the numbers. So as I said, if it's bigger than 0, we are just going to return the input. Now we can go back to our crouching HandIK. I'm going to close the parameters because we are not going to need that anymore. And we are going to normalize every value after the addition, except for the pitch, so the Y value. You will see Y in a moment. YY. So normalize and connect. And if everything works well, you are not going to see any difference, because it's going to be the same angle, just translated to 0 to 360. Okay, so we are gonna normalize the roll and the yaw. And leave the pitch alone. And the next thing we are gonna need is take the out hit normals yaw and our own yaw normalized and check the difference in angles. And we are gonna need another function for that, because if you have an angle of 359 and you have an angle of 1, what normally the difference will say if you just subtract it from one another is that the difference is 358, which is absolutely not true because the difference is actually 2. So I will just create a function that tells you the actual difference between two angles, no matter the direction. Which is actually pretty simple. So if you get two values and add them together, if the absolute value of that is bigger than 180, then you're just gonna return that. But if it's not, you take both values, subtract it from 180, add it together and subtract it from 360, and that will give you the actual difference between two angles. You can write it down and try it for yourself. Or maybe I will just, when editing, I will just put a few examples on the screen so you can see what I mean by that. So basically this function's whole purpose is just to take two angles, A and B, and check it if it's if the different and return the difference between the two angles. So here you can see that I subtract B from A, get the absolute value of that, and check if that absolute value is bigger or equal to 180. And if that condition is true, I am just gonna return the difference. I mean, sorry, if it's false, I will return the difference. The absolute difference. So I don't want to work with negative numbers because the difference should always be positive. And on the contrary, if that's bigger than 180, then that's when I will do the addition and subtraction. But I do encourage everyone to just grab a piece of paper, write down a few angles and try this method on them so that you can understand it and why we are doing it. So I will just drag in our newly created pure function, get the two yaws in. It doesn't matter which order because it will tell the difference either way. And now, based on the difference of that, based on the difference between the object's yaw and the player's yaw, we are gonna multiply the pitch so that, for example, if the player yaw is 90 and the object yaw is 90, and the pitch of the object is 25, what we need is the hand to bend upwards 25 degrees. That's cool. But if I'm standing the opposite direction from the object, I don't want my hand to bend upwards 25 degrees. I want it to bend downwards. So I have to multiply the pitch by -1. And that's exactly what this calculation does. So that checks the difference, and based on that, it creates a multiplier that will multiply the pitch by the amount of how different your angle is from the object's angle, so that your hand will always align with the object. And to achieve that, it's just I'm getting the difference divided by 90, taking away 1, and then multiply it by -1. And now, as you can see, the hand has the correct angle on the object. So if it's downwards, it's downwards. If it's upwards, it's upwards. And the other fun bit is actually, if I am standing 90 degrees to the object, my pitch has to be actually 0%, but my roll has to be the percentage of the object's pitch, because I am translating it, which means that so yes, the roll has to change according to the pitch, so that the hand will have to bend sideways instead of up and down if I'm standing in a different angle than exactly aligning with the object. So for that, I just created another helper function which just tells me 1 or -1 based on how the value it gets. So if it's smaller than 0, I'm just going to return -1, and if it's bigger than 0, I'm just going to return 1. And now to actually work with the roll, what I have to do is get the difference of the pitch and the multiplied pitch. And that can be done simply by subtracting the absolute values from each other. And that's how we translate from the pitch to the roll, so that the roll is how the hand rolls to the side. And now that we have the difference between the multiplied yaw and the multiplied pitch and the actual pitch, we are gonna actually have to change that value according to how, if the pitch is positive or negative. That's why we created the 1 or -1 function. And after the multiplication, we are just gonna add it to the existing normalized roll. And I know it might sound difficult, but it might just be because of my explanation ways, and it's entirely possible that I overthought the whole process. So the roll is basically, so we add a difference to the roll based on how much we had to modify the pitch based on the yaw of the object and the player. And as usual, we are just gonna copy the whole thing over to the other hand. I made way too much space there. Let's just paste the whole thing and connect up the out hit normal and rotator to the set left hand rotation. And since it's the other hand, we have to change the yaw to +90, not -90. Same goes for the pitch, and actually it's not 180, it's both has to be 90 and -90. So it doesn't work the same way as the standing one works. And the roll has to be the opposite as well. You can just copy these values and then play with them later. And since it's the other hand, we actually have to take away from the roll instead of adding to it. And I am sorry if you hear my dog barking. It's just there are quite a few busy hikers in the area and my dog doesn't like them. Okay, let's compile, save, and see what we did. But that one seems to be good. That seems to be good. But let's check if the roll works properly, and it doesn't. It rolls the exact opposite way as it should. So it's bending inwards, rolling inwards. And that's actually an easy fix. I probably messed up the values based on the 1 and -1. So I just have to invert them, actually. And my line trace parameters might not be working too well, because as you can see, the standing one sometimes glitches into the crouching one, so I will have to put them a bit more up so that doesn't happen again. And just so I can see better, I'm just gonna change that to -40 so it goes down a bit more there. You're not gonna see a lot of difference there, just a convenience thing. So yeah, you can now see clearly that the roll is not correct. There you saw the glitching I just told you about like a few seconds ago. So let's actually go back to the crouching HandIK. And this is me searching for the problem. And while I think that function works as intended, maybe somewhere along the way I screwed up something else and it has to be inverted, or I just remembered wrongly. Yeah, because let's face it, I had to use cheat sheets because I forgot some stuff along the way, and to make this tutorial I made cheat sheets and I might not have copied everything as I want. But now the roll works after that slight modification, and I am happy with that. So now let's actually just make it a bit more tidy, and let's create the conditions so that I only want the crouching one when I am crouching, for one, and I don't want to have any of the IKs when I'm running because that just looks silly. So what I need is the desired gait and the desired stance, so I will just search for that and drag them in. These are provided with ALS, so you don't have to create these enums anywhere. So what I want is when I am crouching, I want to have both the standing and the crouching one, but when I am standing, I only want standing and IK. So that's the branch, and the condition is gonna be that the stance is standing and I am walking. Connect that to the false. And I will just return empty when I return an empty return code if it's false, or nothing. Now actually I made a small mistake there. This is for the bottom one, so when it's not crouching. I will just pause it real quick so you can copy this. So you actually need an isMoving variable. You don't have to create that, it's under the essential information under variables. So just copy this, and now it's not equal running and equal sprinting, it's not equal and not equal. So sorry, I made a mistake during this and I had to re-record it with the right values. So basically the desired gait is not equal to running and sprinting, or the character is not moving. And that's where I want the standing HandIK. And now if I save that and play, when I am standing, I only have the standing ones. If I am running, I don't have it. And if I am walking, I have the HandIKs. And when I am crouching, I have all the IKs. And basically that's it for the crouching HandIK. I really hope I helped some of you with this tutorial. Now, obviously this can be improved in many ways, and I will probably improve it along the way and post updates. This is how far along I am. I will try to add a bunch more stuff and keep you updated. But if you enjoyed it, I am glad, and thank you for watching.